Hello everyone, welcome to Basics e-learning. Let us see a problem on Thevenin's theorem. So this is the network they have given. We have to find out the Thevenin's equivalent network across the terminals x and y. So here the terminals x and y are already open. So as the terminals x and y are open here, this minus j10 ohm, that is the capacitance, will not come into picture here, right? So as this is open, there is no current flow in the capacitor. So whatever the total current that is flowing here is only in this first mesh, right? So let us calculate the current here in the mesh. Call this as I. Calculate the current I. I is equal to V by R, or here V by Z, as we have total impedance, as you have a inductance also here. So 10 divided by the resistance 10 plus 3 plus J4. All three elements are in series. So I am adding up to find out the total impedance: 10 ohm, 3 ohm and J4 ohm. And the voltage here is 10 at an angle 0 degree, or simply you can write 10 also. So this, if we calculate 10 at an angle 0 divided by 13 plus J4. So now if you convert this into polar form, you will get 13.6 at an angle 17 degree. So after simplifying, you will get it as 0.735 at an angle minus 17.1 degree ampere. Here also 17.1 you can take it. Now after finding out the current, we have to find out the voltage across these x, y terminals, that is nothing but your Thevenin. Okay, so to find out Thevenin, or the voltage across x and y terminals, we have to find out the voltage across this branch, that is 3 plus J4 ohm. As we have already found the current, so Thevenin or Vxy is equal to the current that is flowing through multiplied by the branch impedance, right? So this is nothing but 0.735 at an angle minus 17.1 multiplied by J plus 3 plus J4 ohm, right? So if we simplify this, this will get it as 3.676 at an angle 36.03 degree volts. So this is the voltage across x and y terminals, that is nothing but your Thevenin. Then we have to find out Thevenin to draw the Thevenin's equivalent network. To calculate Thevenin, we have to replace the voltage source with the short circuit, right, and the current sources by open circuit. So here in the given network, I have only one voltage source. So let us replace this voltage source by short circuit and then redraw the circuit. After replacing the 10 volts voltage source with your short circuit and then redraw the circuit looks like this, isn't it? So x, y. So this is your 10 volts voltage source. I just replaced it by short circuit. So this is 3 ohm for me, and this is J4 ohm and minus J10 ohm. Now let us calculate here Z equivalent across these two terminals. So if I am calculating Z equivalent, it's very clear that this J10 and 3 plus J4 are in parallel, and that is in series with this minus J10 ohm. So directly we can write Z equivalent is equal to 3 plus J4 is in parallel with 10 ohm, that is in series with minus J10 ohm, right? So let us simplify this: minus J10 plus 10 multiplied by this, if you write it in the polar form, 5 at an angle 53.13 divided by 3 plus J4 plus 10, right? R1 R2 by R1 plus R2, parallel circuit, right? So if you do this, you'll get 2.969 minus J 7.83 ohm, right? So this is your Z equivalent. Once you know the Z equivalent and we have calculated this V Thevenin also, right? So this is your V Thevenin and this is your Z Thevenin. Now we can draw the Thevenin's equivalent network across the terminals X and Y, and the circuit looks like this. So this is your Z equivalent, and if you are given with any load that you can draw here, right? So this is my Z equivalent, value is 2.969 minus J 7.83 ohm, and this is my V Thevenin. So write down the value, 3.676 at an angle 36.12 degree volt, right? So this is how you have to calculate the Thevenin's equivalent network for any given network. For more videos, please do like, share, subscribe to our channel. Let us know your suggestions and queries in the comment box. Thank you.